Graphing rational functions, section 4, slant asymptotes. So this is video number 4, hence section number 4 of graphing rational functions. And up to this point, we've discussed steps 1 through 7. 1 through 5 were in the first video on factoring the numerator denominator, reducing, finding vertical asymptotes and the domain. And then we learned that if you have any common factors that cross out in the numerator and denominator, that's what creates a hole in the graph. And then we talked about how you could compare the powers of the numerator and denominator exponents to decide if there is a horizontal asymptote. So we've covered vertical asymptotes and horizontal asymptotes. Vertical asymptotes are vertical lines where the graph can't cross. Horizontal asymptotes are horizontal lines where the graph can't cross. Slant asymptotes are just basically asymptotes that are not vertical and not horizontal. They're lines that are slanted, something like that. Now, slant asymptotes do not always exist. Well, I mean, none of these things always happen. We've seen examples where there is no vertical asymptote. We've seen examples where there is no horizontal asymptote. And there's going to be plenty of examples where there is no slant asymptote. But sometimes there is. And so we need to look at those situations and when it occurs and what the equation of that slant would be. So we, in the last video, did horizontal asymptotes. And there were 3 ways that went, comparing the highest exponent of the numerator and denominator. If the bottom denominator was the larger, then it was bottom heavy. You had the equation y equals 0 as your asymptote. And if the exponents were equal, then you had the fraction from the coefficients. If it was top heavy, there was no horizontal asymptote. So in the case of there being no horizontal asymptote, there may or there may not be a slant asymptote. You will never have a horizontal asymptote and a slant asymptote. It's one or the other, sometimes neither, but it's never both. So if there is no horizontal asymptote, and that occurs when it's top heavy, when the numerator exponent's larger than the denominator exponent. So when that is the case, when there's no horizontal asymptote and the numerator exponent we're saying is larger, when it is exactly 1 degree higher than the denominator, a slant asymptote exists. So we mean like if the numerator has an exponent of, say, x to the 5th, and the denominator has an exponent of like x to the 4th, 5's 1 higher than 4, that's when you will have a slant asymptote. So again, if it's like x to the 5th over x to the 4th, that your top is 1 higher than the bottom, that's when we're going to have a slant asymptote. If it was more so, if it was like x to the 5th over x to the 3rd, then no, there would be no slant asymptote. So it's only in very special circumstances do we have a slant asymptote. First of all, there is no horizontal asymptote because you're top heavy, and the exponent difference has to be exactly 1. Only 1 higher on the top. So that's what requires you to have a slant asymptote to begin with. So it's pretty rare just because it's, very special criteria. So when you know a slant asymptote exists, how do you find the equation? Well, the equation is determined by doing long division of the numerator divided by the denominator. And you don't worry about the remainder. It's not going to divide evenly or anything like that. But the quotient, you ignore the remainder. The remainder is irrelevant. But the quotient is the equation of the slant. So let's jump into a couple quick examples. Here's our first one. G of x equals x squared minus x minus 2 over x minus 1. And so we factor the numerator, and we get x minus 2 and x plus 1. And the denominator is x minus 1. We see that there are no common factors. Nothing crosses out. And we could go into, this is going to give us a vertical asymptote, and that's going to be a restriction on the domain, and yada, yada, yada. But for this video, I just want to focus on the slant asymptotes because we're going to have to do some long division, and that's going to take some time in itself. So you recognize that the exponent of the numerator is 2, and the exponent of the denominator is 1. That means for horizontal asymptote, there is none because this is a top-heavy expression. Top-heavy meaning the exponent of the top is larger than the bottom. So because it's exactly one higher, we will have a slant asymptote. I'm spelling slant wrong. Slant asymptote. And so to find that equation, we have to do long division. So we take our expression, x squared minus x minus 2 divided by x minus 1. And we're going to do long division. So if we remember long division, we've done this in the past, so hopefully this isn't too new. We did do this in previous chapters. The comparison is, I'm dividing these terms basically. X squared divided by x, or you can think of it in terms of multiplication is, how do I get x to be x squared kind of thing. And how do I get x to be x squared? I have to multiply it by x. And x times x minus 1 gives you x squared minus x. And then we change the signs of the bottom row. Your first column cancels out, which is important, otherwise you're doing something wrong. And in this case, our second column also cancels out, and you have a remainder of 2, a negative 2. Now, x doesn't go into negative 2, so that's how you know you're done. And your remainder in this case is negative 2, but it really doesn't matter much. All that matters is this, what's up here. That's the equation of your slant asymptote. Y equals whatever's up there. Let's look at another example. The numerator here has a power of 2, and the denominator is a power of 1, so it's top heavy, so there is no horizontal asymptote. And because it's exactly 1 larger, there is a slant asymptote. And to get that slant, we would divide. Now, there's no factoring that can be done in either of these, so we don't need to worry about that. So x squared plus 9 divided by x plus 2. Now, I made a mistake just now, and I wonder if anybody caught what it is. If you remember when you're doing division, this isn't going to work because there is some missing terms. I should really think of it as x squared plus 0x plus 9. And otherwise, I would come up with some errors there. And so how do I get, all right, so I'm looking at our x squared and x. How do I get x to be x squared? I have to multiply it by x. And that's going to give me x squared plus 2x, because now I'm multiplying this x by the whole thing, x plus 2. That gives me that expression on the bottom. Change my signs. Cancels out. I get negative 2x plus 9. So now, how do I turn x into negative 2x? Well, I multiply it by negative 2. And that gives me negative 2x minus 4. Change the signs. These cancel out. I get a remainder of 13, which really doesn't matter. It's not really has anything to do with the slant. It's all about the quotient up here at the end of the problem. So my slant asymptote is y equals x minus 2. That would be the line that the graph cannot cross. One more quick example. X cubed minus 8 over x squared minus 5x plus 6. Again, we see it's top heavy. The 3 in the numerator is larger than the 2 in the denominator, and it's exactly 1 larger. So we can do long division with this. Now, x cubed, I am missing a 0x squared term, a 0x minus 8. And all that is being divided by x squared minus 5x plus 6. So how do I get x squared to be x cubed? I multiply it by x. And that should actually be over x to the first. Because you see, we always have a common column thing with the exponents. The x squareds are on top of each other, so the first terms are on top of each other, just the constants, the numbers are on top of each other. So x squared times this trinomial gives me x cubed minus 5x squared plus 6x. Change all my signs on the bottom. I end up with 5x squared minus 6x minus 8. And so how do I get x squared to be 5x squared? I need to multiply it by a 5. And that's going to make that 5x squared minus 25x plus 30. And at this this point, like I said, I'm just going to get my remainder at this point. I don't really, care what my remainder is very much, but I'm going to end up with 19x minus 38. Now, how do I know I'm done? How do I know that's the remainder? How do I know I don't now, have another term up here? Because this is x squared. I can't turn it into 19x. I can only turn it into things x squared and up, like x cubed or 5x squared, stuff like that. I can't make it any smaller. So that's how you know you're done. So this is your remainder, and you don't really care about that. But this up here, that's your slant. So your slant asymptote is y equals x plus 5. All right, guys? That's it. See ya.